All right, this first problem is from section 1.1, and this problem is similar to number 1 in that section. And it says, solve the system using elementary row operations on the equations, follow the systematic elimination procedure. Here's the system. And your problem won't exactly be the same, but it'll be similar. Now, first of all, we want to form the augmented matrix. So notice that consists of the coefficients on the left-hand sides of the equation and also the constants on the right-hand side. And I'm going to solve this thing by putting this in what's called reduced echelon form. And that means I want to make this element a 1 and I want to make this a 0. I want that first column to look like 1, 0, 0, 0, 0 all the way down. In this case, we just have 2 elements. But the 1 is already okay the way it is. I want to change this to a 0, though. So what I'm going to do is I'm going to take the first row and multiply it by -4 and then add it to the second row. And that's one of the row operations you're allowed to do. So I'm going to take the first row and multiply it by -4, and then I'm going to add it to the second row. So you don't have to write that down every time, but that's basically what I'm doing. So I'm not going to do anything at all to the first row right now. So this is sometimes called Gauss-Jordan elimination. But I'm going to take the 1 and multiply it by -4 and add it to 4. That'll give me a 0. Now take 4 times -4. That's -16. And if I add it to 7, I get -9. And 4 times -4 is -16. If I add that to -11, I get -27. Okay. So the next thing I want to do is work on this column. And I want this to look like 0, 0, 0 all the way down to a 1. So in this case, I want this to be a 1 and I want this to be a 0. And usually you start by changing the elements that are supposed to be 1s into 1s first. So I'm going to change this into a 1 by dividing that whole second row by -9. So notice that'll make a 3 for that last element. Now I'm going to make this, and I guess I could go ahead and write that as -1/9 times R2 is essentially what I did in that second step. Now I want to change this into a 0. So I'm going to multiply the second row by -4 and add it to the first row. So I'm not going to change the second row at all. It's still 0, 1, 3. But this times -4 plus that is just a 1. This times -4 plus that is going to be a 0. This times -4 is -12. And if I add that to 4, I get -8. Okay, so that is in reduced echelon form. And this is essentially the same as the system. 1x1 plus 0x2 equals -8. 0x1 plus 1x2 equals 3. So clearly x1 is equal to -8 and x2 is equal to 3. So that's the solution of the system. That's certainly one way to solve a system.